Why one discovery made chemistry dangerous forever. At first, it felt like a triumph, a clean breakthrough, a solution so elegant it seemed almost harmless. But from that moment on, chemistry would never be innocent again. Before this discovery, chemistry was largely descriptive. Scientists observed reactions, recorded outcomes, and tried to understand nature's rules. After it, chemistry became something else entirely, a tool capable of reshaping matter at will. And with that power came risks no one fully grasped. To understand why this matters today, we have to return to a time when control itself was limited. Reactions happened when conditions allowed. Scale was constrained by effort and resources. Chemistry could surprise, but it could not dominate. Then one discovery changed the equation. It revealed that reactions could be forced, accelerated, and multiplied far beyond natural limits. With the right conditions, matter could be rearranged faster, stronger, and more aggressively than ever before. At first, the application seemed purely beneficial. Materials improved. Production soared. New possibilities opened in medicine, energy, and manufacturing. Chemistry felt unstoppable, finally liberated from nature's slow pace. But hidden inside that breakthrough was a shift. Chemistry was no longer just learning from nature. It was overriding it. And once that line was crossed, every reaction carried a new question. Not just can we do this, but what happens when we do it everywhere? As the discovery spread, chemistry entered an era of acceleration. Reactions that once took days now finished in minutes. Processes that required rare conditions became routine. Control replaced patience. This new power reshaped laboratories first, then industries. Catalysts amplified speed. Pressure and temperature were pushed to extremes. Chemistry no longer waited for equilibrium. It forced outcomes. At first, the results felt miraculous. Scarcity faded. Consistency improved. Products became uniform and reliable. Entire supply chains reorganized around reactions that could be summoned on demand. But acceleration has a shadow. Faster reactions leave less time for correction. Byproducts form before anyone notices. Small errors multiply rapidly. Chemistry began producing consequences at the same speed as results. This is where early tension appeared. Reactions escaped controlled spaces. Waste accumulated faster than systems could process it. Materials designed for permanence entered cycles built for decay. Scientists started noticing a pattern. The discovery had not just increased power, it had removed natural limits. Chemistry was no longer self-regulating. Human intention became the only break. And intention, unlike chemistry, is inconsistent, driven by demand, profit, urgency. The discovery had given humanity a lever capable of moving the world, but it had not taught restraint. From this point forward, every new reaction carried a quiet risk, not because chemistry changed, but because scale and speed have forever altered its impact. The conflict deepened as chemistry's new speed collided with complex systems. What worked flawlessly in isolation behaved differently when embedded in the real world. Ecosystems, bodies, and atmospheres responded in ways no laboratory could fully predict. Chemists began encountering reactions that refused to stay contained. Compounds traveled farther than expected. Interactions multiplied. Secondary chemistry emerged where none had been intended. The faster reactions moved, the wider their reach became. This buildup carried emotional weight because the discovery itself was not flawed. It had done exactly what it promised. It unlocked control. The danger came from how quickly control became routine. Mistakes that once remained local now propagated globally. A misjudged reaction did not fail quietly. It scaled. Production amplified it. Distribution carried it across borders. By the time consequences appeared, the chemistry had already embedded itself deeply. Attempts to slow things down met resistance. Speed had become synonymous with progress. Efficiency was rewarded. Caution felt like delay. Chemistry was no longer just science. It was infrastructure. The realization grew uncomfortable. Humanity had gained the ability to reshape matter faster than it could understand the outcomes. The discovery had tipped the balance. From observation to domination. From learning to forcing. This was the edge of the climax, a moment where chemistry's greatest strength revealed its greatest vulnerability, power without pause. The climax arrives with a single realization. Chemistry did not become dangerous because of malice. It became dangerous because it became fast. Speed changed everything. Reactions once limited by time and effort now unfolded instantly, everywhere at once. There was no natural pause to observe consequences, no delay to adjust course. Chemistry moved forward relentlessly, obeying only physical law. This moment reframed responsibility. Power was no longer defined by what chemistry could do, but by how carefully it was used. The discovery forced humanity into a new role, not observers of reactions, but custodians of their scale. The resolution is still evolving. Safeguards now matter as much as breakthroughs. Slower processes are sometimes chosen over faster ones. Testing stretches longer. Systems are designed with failure in mind. Chemistry is learning restraint through human decision. This does not undo the discovery. It cannot. The line has already been crossed. Chemistry will never return to innocence, but it can move toward wisdom. Every reaction now carries an echo, beyond the lab, beyond intention, into systems that persist long after the experiment ends. Understanding this changes how progress is measured. Chemistry remains one of humanity's greatest tools. But from this point forward, it demands something new in return: awareness, patience, and respect for consequences that do not appear immediately. Subscribe to join the journey.